Assalamu alaikum. In our last video on reliability and validity, we explained that reliability and validity are the quality evaluators of the research process. These two tools are used to measure the reliability or the consistency of the measure as well as the accuracy of the facts and figures which are collected through these measures. So the central point was to understand what do we mean by measure. Measure refers to the concepts and the questions and scales used to collect facts and figures from the respondents. Therefore, all those are collectively called measures. So in our previous video, we discussed and computed through SPSS the reliability of the measure, and today we shall practice how can we compute the statistics regarding validity or accuracy of the facts and figures collected through the instrument or the questions and the questionnaire. For validity analysis, the commonly known tool is factor analysis, which is a set of tools, a mathematical algorithm which helps the researchers in computing different types of factors available in the data matrix using different techniques like principal component analysis, standard factor analysis, exploratory factor analysis, and confirmatory factor analysis. However, today we shall work on principal component analysis, which is also called common factor analysis, to understand the role of factor analysis as a tool for validity and evaluating the validity of the measure or measurement used by a researcher in his or her research project. But before we proceed, let's have a simple idea about the role of factor analysis in social research. In social research, we commonly develop a structured questionnaire which is based on the relevant literature, wherein the variables known as factors in factor analysis are well defined, as are their attributes, in the sense that literature review refers to the practice that we go there and ask the experts about the definition of the variables. The definitions are made of all the attributes which represent that particular variable. So these things are clear to the researcher, that what are the factors they are looking for, or what are the variables, and what are the attributes as suggested by the literature. However, the factor analysis is run with the intention that whether or not we are accurate in assuming that the questions or attributes we have used in the questionnaire actually represent the variable. So factor analysis is defined by several researchers and scholars in many ways, but all of the definitions, they refer to the same thing, and we shall point it out at the end of these definitions. Factor analysis is a set of techniques to reduce a huge number of data items into manageable size by extracting items with shared variance. It is a statistical technique for identifying which underlying factors are measured by a number of observed variables. Underlying factors refer to the variables that are used in the social research, like leadership style, employee performance. So these are the underlying factors because these are not measured directly, rather through their attributes. Their attributes are the observed variables, which are converted into questions, and the answers are collected from the respondents. While underlying variables, they are not visible, rather, they are computed by the values placed in the observed variables. For example, a question answer observed variable using one or another scale to measure motivation, which is an underlying variable. In social research, questionnaires contain variables with attributes for each variable. Variables are the underlying variables mentioned in the definition of factor analysis. While questions are constructed for each attribute, there can be one or more questions about each attribute or dimension. So, questionnaires bring in answers to questions which are called observed behavior or variables. Factor analysis sorts out the observed variables or items or answers to questions in terms of their correlations with the underlying hypothetical variable. As we said earlier, that there are several types or methods to perform factor analysis. Most commonly known and discussed in the background of social sciences are exploratory factor analysis, confirmatory factor analysis, standard factor analysis, and principal factor or component analysis we are talking about right now. Principal component analysis is a mathematical algorithm that reduces the dimensionality of data while retaining maximum variance in the data set. It is done by identifying directions, which are called principal components, along which the data variation is maximum. So, principal component analysis is also called common factor analysis, principal factor analysis, and principal excess factoring. PCA extracts the factors which have shared or common variance or correlation. Actually, all these definitions are saying the same thing, and that is the factor analysis is a tool which helps the social researcher in testing whether or not the questions the researcher is assuming based on the literature review that these questions are representing the variable which is the underlying variable. Through the observed behavior or the questions and answer sessions with the respondents, the question is that whether these questions are actually talking about the same underlying variable or not. Factor analysis statistically computes the correlations of each item or question with the latent variable and then decides which one is highly correlated, that is taken as the real representative of the underlying variable. The minimum score for the factor or minimum factor loading for the question will be 0.4 that we shall use in this example. There are certain steps we have to undertake the principal component analysis. These steps, which are undertaken before running the factor analysis, two tests are run to check readiness of data for factor analysis. One is the test of adequacy of the sample called KMO test, that is, and second one is the test of suitability of data, Bartlett test, and it is also called Sphercy test, which checks the suitability of data. And third, finally, we will compute the factor loadings of the scores by running the factor analysis. Required minimum scores for the tests, all these three tests are as given by the experts, that KMO must be equal or greater than 0.7. The Bartlett test, second suitability test, or sphericity tests must be equal to or less than 0.05. while the factor loading of each question must be equal to or greater than 0.4. So using these standards, we shall now move to compute the statistics in SPSS, and then we shall come back with the results to discuss them one by one. So let's move to the SPSS. So here is our data matrix with 4 variables. The independent variable or X variable is authentic leadership. The dependent is the employee motivation, while distributive justice and relational justice are used as the mediators. However, since we at the moment are not concerned with these relationships of the variables, rather we have to conduct the factor analysis for the validity reasons of the questionnaire and each variable. As we have already said that factor analysis measures the relations of questions with the factors or the variables, and since we already know our variables and their questions, so we shall use the factor analysis to tell us about whether or not the questions we have used for a particular variable or factor, whether they are really explaining the same variable. If not, then we have to exclude them from our analysis. So let's go to compute the statistics about factor analysis, analyze, and then dimension reduction, factor analysis. Here in descriptors, we have to select KMO and Bartlett test of sphericity, continue. Then in extraction, we have, since we already know our variables, so we don't require factor analysis to identify the factors as well. So we know the variables and we know the number of factors. So fixed number of factors means that we are asking for one factor from the number of questions we shall hand over. 1, continue, and now we shall give the questions. So as we have discussed in the last video, there are 4 variables with 32 questions. Each variable has 8 questions. So question 1 to 8 will be taken into the variables column and OK. Now the results show that KMO is 0.8 to 1, which is far greater than 0.7, and the Bartlett test is far less than 0.05, which is 0.000. Further, the factor loading of all the questions is greater than 0.4. So this variable, first variable or factor, has been verified as having all the questions which are highly correlated with the latent or underlying variable. Next, we shall go for the second variable, scale, factor analysis, reset, and then from question 9 to 16 will be selected and placed in variables column. Descriptives, again KMO and Bartlett. Extraction, 1 factor, continue and OK. Here we can see that the KMO result is 0.68, while we know that we are using 0.7 as the minimum score for KMO. So it means that there must be some problem with some question. At the component matrix, we can see that question number 12 is having lower score, lower than the required 0.4. So that is why the KMO test is coming less than 0.7. So let's go back and exclude this question. Question 12 will be excluded, and again we shall run the test, and now you can see that it is 0.698. So we can assume it as equal to 0.7, and there are all the questions with greater factor loading, that is required 0.4. So in this way we shall keep on computing the factor analysis statistics for all the variables. The next is from 17 to 24. Descriptives, KMO and Bartlett. Extraction of only one factor, and OK. And here the results are satisfactory. 0.7 is the KMO. Bartlett test is also significant, and there is the score of greater than 0.4 which is required. So it goes well, and the final variable is from 25 to 32. Descriptives, KMO and Bartlett test, factors 1 and OK. Again, here is the problem. The KMO score is 0.66, which is less than 0.7. So there must be some problem with the questions. Yes. Question 26 is giving the factor loading of 0.293, which is far less than required minimum score of 0.4. So let's go back and exclude this from the analysis and see what happens. Yes. Now the result is 0.69, which is close to 0.7, and all the questions used as the representatives of the underlying variable, they all are having score or factor loading of 0.4 greater than 0.4. So now let's take these results to the slideshow and once again discuss them and explain them with reference to our requirements of using validity analysis or the factor analysis as the tool for validity to validate our data that have been collected from the field, ready to answer our main research questions. So let's go back to the slideshow. We left for SPSS from this screen where we had the required minimum scores for the tests to qualify acceptability, that these are the standards which will be used by the social researcher while deciding whether or not the factor analysis has approved all the questions or which of the questions need to be removed from the analysis because they are not adding to the validity, rather they are making things invalid. So with this standard we shall proceed to decide about the results. As in case of first variable, we have already gone through the practice that all the factors they had greater than 0.4 factor loading, so they were all significant, and the KMO and the Bartlett tests both were significant, as we can see that 0.8 is the KMO, which is greater than 0.7. So all questions have factor loading greater than 0.4. Therefore, on first variable is the decision will be that variable 1 is validated by the tests of factor supported by the KMO and Bartlett test of sample adequacy and sphericity or suitability of data respectively. Then we computed the second variable, that was the dependent variable. In first run we got the KMO equal to 0.68, which was less than 0.7, and we found in the component matrix that the question 12 was being loaded with 0.317 as the factor loading. So we excluded this question 12 from the analysis and ran the factor analysis once again. Then we got 0.698 as the KMO score, which was close to 0.7, acceptable, and all the questions they were having factor loading of greater than 0.4. So variable 2 is validated by factor analysis with KMO and Bartlett tests respectively. Question 12 was excluded from the computed variable. Then the third variable, that was mediator 1, about distributive justice, we got the sufficient scores on KMO as well as Bartlett test and the factor loadings. Therefore, the question 3 was supported by all the variables as related with the underlying variable. So variable 3 is validated by the tests of factor analysis supported by the KMO and Bartlett tests. Then the last variable, mediator 2, the relational justice. First, the results came out with KMO of 0.66, which was less than 7. So we checked the component matrix or the table showing all the questions, that question 26 was getting 0.29 as the factor loading. So we excluded this variable and then again used factor analysis to compute the scores. Now the score was 0.699, which is acceptable, along with all the questions getting greater than required 0.4 as the factor loading. So variable 4 is validated by factor analysis with KMO and Bartlett tests respectively. Question 26 was excluded from the computed variables. The summary of the results are shown in this table, that variable 1, 2, 3, 4 all had 8 questions each, but then through factor analysis in variable 2 question 12 and in variable 4 question 26 were excluded because they could not pass through the filters of factor analysis as the strong and valuable contributors towards the underlying variable. The results show the reduction of some data which lacked shared variance below the required critical value from the data set. Questions 12 and 26 were excluded from the computed variables in the sense that the computed variables were recomputed to accommodate the suggestions by factor analysis that which of the items or the questions are not making statistical contributions toward the underlying or the latent variable of the research. So that was all about factor analysis, and In this lecture, we have tried to explain the concepts of reliability and validity. These terminologies are not so simple to define mathematically only. Therefore, learners must hold a basic idea of the constructs and keep improving their understanding through theoretical as well as statistical experiments in real-world practices like field surveys and applications of reliability and validity tests which are available, which are existing, and which are coming with the technology, because the experts are continuously working on these things. So in this way, the researchers or the social researchers, they will stay updated if they keep in touch with the market, with the practical technology. Thanks a lot and see you in the next video.